Hey guys, welcome back. Again, you didn't go anywhere, I did. But hopefully you guys understand what we covered. If not, you can pause here or rewatch the previous video or the video before that. And I think we're ready to move on and make this a wee bit more complicated in the next 15 minutes. And what we're going to do, we're not going to change a lot, but we're changing enough that we can give this new type of problem a new name. And the name we're giving it is an initial value problem. Now, due to the lack of real estate that I have on the board, I may write this as IVP in future, initial value problem, and it's not overly complicated actually. It doesn't change a lot up until the very end. And so what we're going to do to introduce it is we're going to do the exact same example as before, except I'm going to make it an initial value problem. And so that means that you're given y equals y prime, but I'm also going to tell you that y of 0, remember y is also a function of x, right? So y of x is going to equal some function of x. I'm telling you that when x is equal to 0, that other side of the function is going to evaluate to 3. Alright? So remember, our final answer from the previous time that we did this was that y is equal to c e to the x. Alright? So we're going to go through the problem again, but what I'm going to explain right now before we get started so you guys can see the difference is that I'm saying y, remember, this is y of x, which is equal to this function of x right here, all right? C e to the x. Thing is, it's not very satisfying to see this arbitrary constant, this number that we don't know, because it's essentially another variable, right? We just know that it's a regular number, so we don't really care, but we don't know what the number is. And so what this is going to allow us to do, this is what makes it an initial value problem, this bit right here. And what this is going to allow us to do is figure out what this is, because it's telling us that this is y as a function of x. When x is equal to 0, see how it's written in the same spot as the x? When x is equal to 0, this side of the equation is going to equal 3. So what this is telling us is that when x equals 0, that means instead of c e to the x, we know x is 0, right? So this x can be replaced by a 0, and then this c times e to the 0 is equal to 3. All right? So that's what we're going to come to in just a sec. We're going to go through the whole thing very quickly, just so that you guys can see it one more time. I shouldn't have erased that. Whoopsie. Y of 0 is equal to 3. We're going to go through the whole thing one more time, kind of quickly right now, just the first part, so you guys can see that this only comes in at the end. Alright? So, first things first, we pull this y prime over to the other side, and it becomes negative because we pulled it across the equal sign, so we got negative y prime plus y equals 0, because there's nothing left over on the right side. We don't want this to be negative, so we're going to multiply everything by negative 1, and then that becomes positive y prime minus y equals still 0, because it doesn't matter if it's positive or negative, right? Now, the form we wanted this in is y prime plus little q of x times y is equal to little g of x. And so what this has taught us, looking at this line and this line, is that we can see that g of x has to be this 0 right here, right? And what we can see also is that this is right here a negative 1 essentially. That's a 1 hiding in there, but we don't need to write the 1 because it's just a 1, right? So we know that there's a negative 1 camping out in front of the y. But down here in the original formula, the thing that camps out in front of the y is plus q of x. So what we know is that this positive q of x is equal to negative 1. So we know g of x is equal to 0, and little q of x is equal to negative 1. Alright, that much we figured out before. Then you go to calculate mu. That's the first step after you've figured out what g and q are. You go to calculate mu, which is e to the integral of q of x dx. The plus c doesn't matter when you're done. Q of x is just negative 1, so this becomes e to the integral of, well, negative 1. I'm going to pull out that negative 1, so I'm putting the negative sign there, and I don't need to write the 1. And then all that's left on the inside is the dx. That evaluates to e to the negative x, right? Good. So, if you need to pause there, okay, I'm going a little bit fast, but I'm going over it for the third time now, so hopefully you guys have got it. If not, back up or pause it or rewatch it tonight when you get home. So now we know that, whoops, so now we know that this is mu, right? We know that mu is e to the negative x right here, mu. We know that now, right? And now what we need to do is we need to figure out what y is. And so we know g is 0. I'm going to just make a small note up here. G is 0, q is negative 1. Alright, that's right up there. Okay, so now we know y is equal to, from our formula, 1 over mu of x times the integral of mu of x, g of x, dx plus c. Right? I'm going to get rid of that right there. Alright, so we know mu of x is equal to e to the negative x, right? And we know that this is the formula over here that we need to use. The plus c we didn't need to write, but it simplifies things a lot. Plugging in mu of x equals e to the negative x, we get y equals 1 over e to the negative x times the integral of e to the negative x. G of x is 0. So it's e to the negative x times 0 dx plus c. Alright? Now, this 0, if you want to think of it as a constant, you can. It might simplify your life. Or you can just remember that if you're multiplying by 0 here, this whole thing can just kind of go. Alright? This whole thing can just kind of disappear. Alright? If you want to think of it as a constant, you can pull the constant out in front, and you're going to have 0 multiplied by some integral on the inside. 0 multiplied by anything is still 0, so we can say with a pretty high degree of confidence that this whole thing right here evaluates to 0. And then we just have the plus c at the end that we're going to tack on. We're going to put it out up here just to save some board space, and I'm going to get rid of that from the end over there. If you guys are still confused by this, please find a way to let me know, and I will make a separate video clarifying how that integral is 0. Alright, I can go over it a couple of different ways. Now, last bit, before we have to add to the problem, e to the negative x in the denominator. So if you have like a to the negative n, in like just like any random number, a to the negative n, it would be the same thing as 1 over a to the n. Alright, so that's how the exponent law that we're working with here actually works. Similarly, 1 over a to the negative n follows the same pattern, and it's the same thing as a to the positive n in the numerator. So here, this is in the numerator, down here, this is in the numerator over 1, right? So that's how that bit right there works. And so what we can do is this is 1 over e to the negative x. And so what we can do is we can just flip that and make it e to the positive x, right? If we simplify, I'm going to get rid of this little extra bit of junk right here. If we clean this up a little bit, we get y equals c e to the x, right? We already got that answer. This is the third time we've got that answer, right? Now, we've been told an extra piece of information this time. Remember that y is a function of x, so this 0 right here is talking about our x value in this very specific case. And what it's saying is that when x is equal to 0, y is equal to 3. All right, that's how this line is supposed to be read, all right? This is saying that y, when x is 0, is 3. When x is 0, y is 3. All right? And so we know, looking at this, whoops, this is a function of x right here, right? And so we know that this x right here is 0. But this whole thing is equal to y, and we know that when x equals 0, in this case, y, we've been told, is equal to 3. So we know that c times e to the 0 is equal to 3. All right? Now, any number to the exponent 0 is what? Pause if you need to. Hopefully you guys remember. Hopefully you didn't have to take a guess, but if you took a guess, hopefully you got it right. Any number to the exponent 0 is 1. So what this is telling us is that c times 1 is 3. Any number times 1 is just itself. So it's telling us that c times 1 is c, and c is equal to 3. So what we know is that this c is 3. That's what we got out of this. And so our final answer for this question then becomes, quite simply, that our y went from, so before we had y equals c e to the x, now we've used this thing over here to figure out down here what that c actually is as a number. And so what that tells us is that y is not just c e to the x, but in this specific case, with this specific initial value given, y is equal to 3e to the x. And that is the function of x that satisfies not only this condition, but also this condition over here. So it has to satisfy both. If this was just a c, like right here, that satisfies this condition, but only this condition. This one, with the 3 here, satisfies this condition and this condition. That's the difference. I hope that makes sense. I spent a lot of time on this question and this example, but I know I've gone a little bit quick, so that's why I've been reiterating so much about the example that we've done and this initial value problem. I wanted to take it slow and then work through it at a decent-ish pace. What I'm thinking of doing next is hopefully some more examples and then second-order differential equations, just a little bit. And pretty much that's differential equations where you're working with second derivatives as well. They do tend to be longer, so I think I'm just going to introduce the idea, but when it comes time for your guys' quiz, I don't think I'm going to worry too much about it. But yeah, there was some problem accessing the videos. I was trying to find the videos and find the YouTube channel by myself, and there was some problem with me changing the name of the channel from my Gmail name to what I wanted the YouTube channel to be, and so it kind of was impossible to actually find it for a bit, but that seems to be resolved, so hopefully you guys haven't had a problem with that. Hopefully you guys understand what we've covered today and last week, and I will see you guys on Wednesday. Send me an email if you have any questions. Otherwise, have a good one.